In this video lesson, we will learn about composite figures. So what these are combinations of figures. So several different types of figures put into one more complicated shape. And we'll actually just jump into some example problems right away. It's the easiest way to explain them. So here we want to find the volume of the figure. So here's the strategy. We separate it into shapes we recognize, and we calculate the volumes of those shapes. So for example, I could take the bottom part, which is shaped like a box, and this is a rectangular prism. And then I can take the bottom part, the upper part, and the upper part is half a cylinder. So we have a box and a half of a cylinder. So we calculate both of these areas separately, and then we can add them to get the volume of the whole thing. We calculate both the volumes separately. So let's start with the box. So the volume of the box, B, is equal to, well, it's equal to the base times the height. And this is a square prism, or rather a rectangular prism actually. But in any case, calculating the area of the base is very easy. Here I'm going to redraw the base flat. 3 and 8, and this 3 and 8 base extends 2 centimeters upwards. So it's 3 and 8 gives the area of the base of 24, and then the 2 centimeters is the height, and that's what we're going to multiply by to get the volume. So h equals 2. And right now I'm not writing any units, but I'll add them in at the end. So we have 24 times 2, which is equal to 48, is the volume of the box. Alright, now we have the half a cylinder put on top of it. So the cylinder has a similar formula for the area. It's also base area times the height. In this case, the base is a semicircle, so half a circle. So here's the semicircle, but you could pretend like there's another equal half on the other side. It doesn't exist in this drawing. So eventually we're going to have to divide by 2, but the base area is then 1/2 pi r squared. 1/2 because it's only half of that circle. See, I erased the other half. And that is the base. And we have diameter 3 because of that rectangular side. That 3 centimeters is also the diameter. So the radius is 3 divided by 2. So the base area of this figure is 1/2 pi times 3 over 2 squared. And that we simplify, we get 9 pi, or 1/2 pi times 9 over 4, which is 9 over 8 pi. There. So that's the base area. And now that we know the area of the base, we just multiply it by the height to get the volume. And the height is 8 centimeters. In this case, the height is this distance from one semicircle to the other semicircle, because those are the two bases. So then here you can see I'm highlighting all the equal heights. Those are all lengths equal to the height. And as you can see, they're all equal to the one, which is 8 centimeters. So the height is 8 centimeters. That's the distance between the two semicircles. So we multiply 9/8 pi times 8, and of course we get 9 pi. So we have so far volume of box is 48, volume of half the cylinder is 9 pi. So the volume of the whole thing is the sum of the two, 48 plus 9 pi. And we can leave it in this form Or we can also write it as a decimal. It depends on what your textbook or your teacher asks you. But if we calculate the decimal, we just plug it into the calculator, and we will get 76.27. So either one of these works as the final answer, depending on what you want. All right, now we're going to do another example problem. Just let me erase all of this. So now I want to find the volume of this figure, this sort of ice cream cone. So once again, the strategy is separate the figure. So first, on the top of the figure, we can see a half a sphere. And then under that, we have a cone. So you gotta recognize these shapes individually and separate the more complicated figure into both of them. So we're gonna start with the half sphere. So the volume of the sphere, in general, the volume of spheres, the formula is, if you don't remember, it is 4 over 3 pi r cubed. But right now we only have half of that. We have a half of a sphere. So we divide by 2. We multiply by a half. And then that's times 4/3 pi r cubed, the whole volume of a sphere. And the radius here is 1. So we have 2/3 pi r cubed because of the 1/2. And then we plug in r equals 1. And that gives us 2/3 pi times 1 cubed. And 1 cubed is just 1, so we get 2/3 pi. So volume of a sphere is 2/3 pi. Alright, now we gotta calculate the volume of the cone, the second component of this complicated figure, this composite figure. So here I flipped the cone over so that it looks more familiar. And this is the radius equaling to 1, I'm indicating. Then here we have the height, and the height is labeled as 7 in the original drawing. So now remember that the volume of a cylinder involves the area of the base. And the base is just the circle of radius 1. So calculating its area is pretty easy. So volume of cylinder, I remind you, is 1/3 base area times height. And then the base area is pi r squared. R is 1. So we get pi times 1 squared, and 1 squared is 1, so we just get pi. So we have 1/3 pi. And then we multiply that by the height, and the height is 7. So we multiply these together, we just get 7/3 pi. And that's the volume of the cylinder. So now the volume of the whole thing. The whole thing has volume equal to the sum of the volumes of the half sphere and the cylinder. Or cone, it's a cone. So volume equals volume of sphere, half of it, plus volume of cone, which is 2/3 pi plus 7/3 pi. We add these, get 9/3 pi, which is 3 pi, and this is already an acceptable answer sometimes, but if you want a decimal, you can plug this into your calculator, and you'll get 9.42. So either one of these works as the final correct answer. So I hope that this helped. Thank you for watching.